Hello, I'm Tony Dubio. I'm a product solutions architect and I focus on network automation for Ansible. I'm a part of North America Public Sector NAPS and I'm out of Raleigh, North Carolina. Today I'm going to provide you with a short demonstration that will show two separate device domains where we will use Ansible to automate the configuration management of Palo Alto firewalls and Cisco routers. Before we dive into the demo, let's take a quick look at the backdrop for our use case. In this demo, we will use automation to control and configure policy to provide access to a web service. This web service is accessed and configured typically manually by the network team through the corporate or internal private mission network to access the web server and to provide connectivity based off of policy. Similar to that, we also have a separate team that manages the Palo Alto firewalls that provide connectivity from the external networks to that same web service. In this case, we have two separate VPC networks set up in AWS. The AWS component of this really has no bearing on the demonstration, but just wanted to point out that these are two separate networks that are unable to connect to each other. So we do have some segmentation that's built in to this particular use case. Now, in terms of making changes, automation will allow these teams to make the changes more quickly and to simplify the process. And more importantly, this should help reduce mistakes, considering that these types of policy changes are made quite frequently as they must manage commissioning and decommissioning new services in this infrastructure, and also the challenges just inherent to two teams trying to work together and in a common process that has been codified manually, and how can we improve that through automation. Now that we're familiar with the use case, let's take a look at some of the key takeaways that I hope you'll find useful as you see the demonstration. First and foremost, Ansible is simple and powerful. It's simple in the sense that many people can get started very quickly. There's a low barrier to entry. Most of what you learn with Ansible is around YAML syntax and building playbooks. So that doesn't take, a huge amount of effort like learning a full programming language. And there's tons of enablement available to help people along in that regard. And it's also powerful in the sense that Ansible is provided as a platform with the Ansible Automation Platform. And the platform provides you with key capabilities to manage your automation in production at scale. So some of those capabilities that you'll see in this demonstration that will be highlighted are roles-based access. So managing multiple organizations, multiple teams, and providing separation of who has access and what level of access that they have for a particular role. So in this demonstration, you'll see that we have two teams. We have the PAN firewall team, and we have the networking team that's responsible for the Cisco routers. A third component of this is self-service, which is important, and it kind of it has a linkage back to roles-based access because sometimes we may not want to provide access to actually configuring content or manipulating any of the configurations. We just want to provide self-service for those that need to consume the automation, so that way they can use it in a self-service way. And in Ansible, we call those surveys. So we'll see some examples of how we can do that. Provide access to the automation without providing access to all the underpinnings of the platform. Workflows. So this is one of the most powerful components that you'll probably see in this demonstration, mainly because it provides orchestration, where playbooks are focused on tasks, where we automate tasks within a playbook. So that's akin to scripting. Whereas workflows is full-blown orchestration, where we can take those scripts, or in this case the playbooks, and we can stitch them together and add additional logic and conditions as part of a workflow with integrations into other systems outside of the automation platform, which is very hard to do with just scripting and trying to manage that as command line. So what you'll see in this demonstration is that we have the ability to provide notifications. We could use integrations to open up tickets, all a part of a workflow And more importantly, the workflow also includes an aspect of multi-domain. So we're working with routers and firewalls with two different teams. So in this use case, we'll use parallelism where we can run two work streams as part of a common workflow. Lastly, testing is paramount to reducing errors and providing very stable and fidelity in terms of the automation that you're building in these environments. So we recommend pre-checks, post-checks, introducing as much testing as you can in these environments to ensure that you have a high likelihood of success. So with that in mind, we'll show you some validation of configuration state in terms of the configuration, syntax being proper so that the device can accept it, as well as operational state. So what is the intent of these configurations? Sometimes we may send a valid configuration in terms of a router or a firewall, but the configuration is not valid as part of our single source of truth or the baseline config and the outcome that we're expecting with that configuration. So in this demonstration, we need access to a firewall. So if we're providing a valid configuration from a syntax perspective, but it's not opening the proper ports for access to the service that we're connecting to, then we would need to test for that. And you'll see that in the demonstration. Okay, so let's go ahead and log into the Ansible Automation Platform Controller. I'm going to log in first with PAN. So this is an account that I use that has access to the Palo Alto automation. And what we can see from this is that this particular account has limitations placed upon it because of roles-based access. And one of the things that we'll notice are the automation. In this case, these are job templates. They only are pertaining to Palo Alto firewalls. So one thing to note is a job template is how we can manage and invoke a playbook within the Ansible Automation Controller. So if I click on one of these, the pan backup, you can see that it maps to this particular playbook. Now, some of the other constructs that I want to show you, I do not have access because of this particular role for this user. So if I go to projects, I'm not able to see any pertinent information there. The same thing with inventories. Right, so this is for the Palo Alto team. They only need access to the playbooks and nothing else in the Ansible Automation Controller. All right, let's log in as config, which should give us access to everything that we need. And this time you can see that we have job templates for the config management that map to the Cisco routers as well as the Palo Alto firewalls. In addition to that, we have something called a workflow. So let's go ahead and take a look at the workflow. So the basics of a workflow, and again, workflows are more around orchestration. So we have the ability to manage, multiple playbooks. Each playbook maps to a job template. And then we have other constructs and conditionals and logic that we can use as part of our workflow. So one of the constructs is blue. So we can see here from a start of the workflow, we have these two blue lines, which means that we have parallelism. So that way, not everything has to be linear, one after the other. We can have two work streams that are initiated at the same time because configuring the Cisco routers doesn't have a dependency on configuring the Palo Alto firewall. They're both working towards a common outcome, which is to provide access to that web service. But we can see that we have, very similar workflows or work streams between the two, where they both start by deploying a configuration, and then we have these two conditions. So the green line indicates if we have a success. So if we send a configuration to a Cisco device and it's a valid configuration from a syntax perspective, then this would be a pass and it would move forward to verify. The same thing with the Palo Alto firewall. If we have green here because of a successful configuration push, then we would move to verify. However, if we have a failure, those are indicated by a red line, right? So red is indicative of a failure. So with that in mind, if we deploy a configuration, we would roll back that specific configuration. And that's why it's named scoped. Scoped would mean instead of rolling back the entire configuration, we're just rolling back the config that we pushed into the device. And then from that, we would move into a notification step. So we always have a blue line here if we go to a rollback because we want to notify the network team when the network configuration doesn't work. And then we would want to do the appropriate troubleshooting to fix whatever that root cause of the issue was. Same thing with the firewall team. If we roll back the firewall configuration, then we would subsequently notify the firewall team. So a notification could be an email, it could be chat ops. So any of the chat tools in my environment, I'm using Slack, but your environment may be different, but that's okay as long as it has an API. We can notify teams using those types of tools. Now, this is called an approval step because we see the pause icon here. So what happens here is that if we have a failure, then effectively we stop the workflow, and then after notifications, folks do whatever the necessary troubleshooting is, and at some point in that workflow, we have a person with roles-based access to provide an approval. So that approval could be initiated directly to AAP, from the GUI interface, or it could be driven from the API, from a playbook. There's integrations into other tools like ITSM tools like ServiceNow or change management tools where effectively through an API, then they could provide access to this approval, and then we can thus move forward in our workflow. So that would mean in this case, we would push a good configuration, after troubleshooting, what's the config change that we need to make? So we would replace the bad configuration effectively. And then we would go through a verification step. So these verifications here are not so much like syntax specific. That's what we're checking here with the rollbacks. So when the device says no, then we have a hard failure, we roll back to config. Sometimes we have a configuration that is suitable or acceptable from a syntax perspective, but it's not providing the correct outcome, right? The intent of the configuration to our environment. So in that case, we would do more of an operational state check to say, hey, in this case, do we actually have access? Can we access the web service from the internal infrastructure, from the Cisco side of things? And in this case, it would be the same type of testing, but it would be established from the outside, the untrusted side of the firewall. Can we access the web service from that direction? And if the answer is yes, then we would move forward to backing up our configurations. So normally I add a configuration backup step to the end of a workflow because at this point we know this is a known good configuration, and we can use this configuration as what we would typically call an intended configuration that we could use to check against, right? So we can run a diff against it later to see if configuration has drifted at some point. Maybe somebody has went outside of automation to the out-of-band connectivity and made a change there. So the next time that we go to make our change, we can become aware of that because it's different than the backup configuration or the intended configuration, and then we can decide either to keep that configuration or to override it, depending on what our policy and our best practice is for that type of situation. Starting the workflow and fast forwarding the video. Okay, great. It looks like our workflow completed. Both the Cisco router and the Palo Alto firewall were able to deploy their configuration to create a policy that establishes connectivity to the web service. So we can see that each one of them went through a verification step. So if we look at Cisco, we can see that we were able to find the title of the web page. And then we also have an assertion to say that if we were able to connect from each router, then we pass that particular assertion. So assertion is effectively a way that we can introduce into a playbook, a way of doing an operational state check. So if we go back to the workflow and we look at the configuration that was pushed from the Cisco router, we can see that we made some changes. So if I just pick one of the routers here, we can see from that we sent commands over the wire. In other words, these are serialized data that was sent in a native command line format from an iOS CLI router. So this is what it would have looked like from the console. Actually, because we're working with a module, the iOS configuration modules, in this case, we are working with structured data. So in the collection of modules, each one of them has the ability to collect a diff. So first it establishes the before state. In this case, we can see that we had an existing access list, but what we're more interested um, in the before state, it doesn't exist, is the access list that was called corporate for the internal connectivity to that web service. So in this one, we do have that applied afterwards. So this is the structured data of the configuration, and what's important for us is the port 80 connectivity to the inside private IP address of that web server that was running in at Amazon VPC. And again, these were the configs that were pushed to the device. Similar situation with the Palo Alto firewall and those collection of resource modules. So if we go back and click on the pan firewall and the output, then what I can do is scroll down a little bit further here, and this one is the security policy. And as we look into here, we can see that we're opening up the service HTTP, which allows us, or it's one part of the configuration that allows us to connect to that web service over the public internet. The other key configuration is the NAT policy. And we'll actually alter that policy to see what this looks like if we had a mistake. So if we introduce a failure, how would we be able to pick that up in our workflow? But before I do that, I just wanted to show you something real quick in terms of self-service in the roles. So if we look at this, if I go back and start it this time, then we have a pop-up. And it's prompting us for information. So port 80 for the routers, port 80 for the firewalls, and then it converts those into variables. Again, these are called extra variables. And if we launch it from here, then it would use those variables would override any of the existing variables because of a precedence. So we're not going to do that. Let's go ahead and let's create that issue with an error, the pan Cisco inventory, and we'll look at the groups. We'll take a look at the firewall, the pan group, the host, and the pan OS firewall. And we can see this is a configuration that was actually pulled in because our inventory source is a project. The project points to a GitLab repository, and that gives us access to all of the playbook files and roles and host variables. Um, and those host variables that we use to populate the host on the controller. So that's what we see here. So I can actually edit it from the GitLab, which takes a little bit more time or additional steps, but I'll just edit it from here. So by going into here, I can see the configuration that we have for the firewall and structured data. And something that would be critical is the NAT policies. So if we were to change this to another port, it actually wouldn't work. Right? So if we change the port here, that will give us a problem. And I'll save that. And we'll go back and we'll run it again, and then we'll find that our validation will catch that change for us. So right now we have a working web page. So if I go here and bring it up, you can see that we can connect to the web page through the untrusted or the public side of the firewall, and we're going to break that now. So if I go back and we'll run it again, and keep in mind we didn't alter the Cisco, so the Cisco should still succeed all the way through. So we'll go ahead and we'll check up here, and we can see from there we're unable to access that web page. And if we click on the verify here, we can see that our assertion this time it failed, right? So we were expecting a response of 200 back from the URL. We were unable to connect, so that was a failed condition, right? So it was a valid configuration from syntax into the firewall, but we were unable to connect to the service that we expected to. So this was a check, that we would use for an operational state check. So what we can do is we can go back and we can take a look at the approval step that we saw here, and we notice that we're paused. So if we click into this, we can accept the change, but first we need to fix the problem, and then we can return to the approval step. So what I'm going to do is go back to where we calls the issue. So into the inventory, into the groups, into the pan group, and into the host. And then we're going to look at the variables that were read in from the repository. And we overrode that by modifying them. So we're going to go back and fix that issue. Fix this issue right here, port 80. Oops, save. Still in this pause state of an approval. So if we go in here, we have this button. We could also access this button to approve or deny or cancel the workflow from an API or from an integration to like a ServiceNow, ITSM, or some other change management tool that we can point, back to that API. So we'll go ahead and manually approve it here because we have the roles-based access level, to do that. And we can see that that kicks off our job again. And if we go back to the workflow, we'll see it continue. Verification again. So the second verification, and as we scroll down, we can see that we were able to find the title of the web page, and we passed the assertion. And if we go back up to here and refresh, we can now access that web page. So let's go ahead and wrap up this video. Thank you so much for watching this video, and I hope this demonstration proved out all of these key takeaways.